Hello everyone, this is Hw11 from class EL6303. In this video, I will solve question 2 in homework 11. So in this question, we are given three functions. The first one is f of v equals to e to the power of minus absolute value of v. And the second function is f of v equals to the sine of v squared over v squared. And the third function is f of v equals to 1 when the absolute value of v is less or equals to alpha. Otherwise, it's equals to 0. In this question, we need to justify these three functions may represent an autocorrelation function of a WSS stochastics process by setting V equals to tau, or a spectral density function by setting V equals to omega or both. So, which function of f of v may represent either or both? We need to explain our answer. So, we need to look at the definition first. If RFF of tau is autocorrelation, it must meet two conditions. First one is this function is even and is less than the value of 0. The second condition is to conduct the Fourier transform of this autocorrelation function and is non-negative. If RFF of tau can meet those two conditions, then it can be an autocorrelation function. Otherwise, it cannot be. So for S of omega, it could be a power spectrum of a WSS power process of x of t only when S of omega is non-negative. It can meet this requirement. Could be a power spectrum of x of t. So let's look at the first function first. The first function is equals to e to the power of minus absolute value of v. So we already know that it's common sense tells us that it's always less or equals to f of 0. That means less than or equals to the e to the power of minus 0. So let's look at the Fourier transform of this function. According to the formula definition, we should get is equals to 2 over 4 plus omega squared. Clearly, it's non-negative. So it could be an autocorrelation function. And for the Part B is f of v equals to s of a sine v squared divided by v squared. Clearly, it's an even function. And let's look at whether it's always less than the value of f of 0. So first we need to conduct the limitation for this function first. When tau is approaching to 0, so this function could equals to, I use the conduct derivative method to see what's the value of this limitation. So because the denominator is 0 when tau is approaching to 0, and the denominator is also 0. So we have to conduct the derivative. After that, I can get when tau is closing to 0 and sine squared of tau divided by tau squared equals to 1. So that means every f of v should less or equals to f of 0. And this function's Fourier transform should drawn like this. Clearly, all its value is non-negative. Then it could be the autocorrelation function. And for the last one is the function looks like this. F of v equals to 1 when the absolute value of v is less than alpha, otherwise it equals to 0. So this function's value is even because the picture we can draw like this. And to conduct the Fourier transform of r of tau should equals to the 2 times sine alpha omega divided by omega. So it's non-negative. Clearly, it's not a autocorrelation function. And now let's look at whether it could be a power spectrum function for the x of t. Because this function looks like this, it's non-negative, so it's a power spectrum function. Could be. So this is the answer for question 2 of homework 11. Thank you.